Hello, and welcome to this T-Level Tactics video on ACID and normalization for Root Core 3 data of the T-Level Digital Support Services course. And in this video, we're going to identify the properties of ACID-compliant databases, and we'll also apply normalization techniques to some data. Before we get started, T-Level Tactics videos are not endorsed or sponsored by any education institution or qualification awarding body. And T-Level Tactics videos should not be used as a replacement to any classroom learning you might be receiving, as the discussion and practical activities with your peers and lecturer will help to expand your thinking and comprehension of the topic. Instead, these materials are best used as preparation material or as a revision to reinforce your learning. These videos also cover the same content of required knowledge for Root Core 3 of the T-Level Digital Business Services course. However, they will be more contextualized towards IT support roles. Let's get started and find out what ACID-compliant databases are. For databases to work effectively, they need to provide data integrity. And we've looked briefly at this before, but there are 6 elements required to ensure this. You must have accuracy, ensuring the data is correct and free from errors. Consistency, where data held in multiple systems should be updated to be the same across each of them. Completeness, where all required data you need to operate should be present. Validity, where data should be in defined formats and match specific data types. Timeliness, data being up to date and relevant to context. And security, where the data should be protected from unauthorized access and any unwanted changes. Databases in large organizations could be changed by multiple users at any one time. This could be hundreds or even hundreds of thousands of users. And all of these users could be spread across the world. Think of social media platforms, for instance. There are millions of users on Facebook. These users upload content to a database, and when you look at a profile, you query that database for results on an individual. And your feed is also a database. It's a query result based on certain criteria that platform has assumed you will be interested in. And millions of people use this every minute of the day, so it's an extremely busy database. Effective databases use a set of principles called ACID that help dictate how they operate. And ACID ensures that data isn't changed or removed accidentally while the database is in use, or if something happens during data transmission. ACID is an acronym, and it has 4 elements: atomicity, consistency, isolation, and durability. With atomicity, each time the database is changed, where data is removed, updated, or added, it is treated as a transaction. Each transaction is a single unit of work. And this unit of work will need to be completed in full or not at all. If the database only receives some of the instruction, it won't action it. For example, if a bank transfer fails halfway, the transaction should not leave the account in an inconsistent state. With consistency, each transaction must abide by all existing data validation rules and conditions. Data cannot be changed from one state to another unless it meets all of the rules and conditions. For instance, if the current data we have is a currency number and a string is entered, this transaction should be rejected because it doesn't meet the data type. Similarly, if the data should be unique, such as being a primary key, then no duplicate data should be accepted. With isolation, transactions should be independent to each other. The data and changes to be made in one transaction should not be visible to any other transaction until it's been completed. For example, if 2 customers are trying to purchase the same item online and there's only one of them left, then both customers should see that there's one item left, even if they both have it in their baskets. The stock should only update once one of their purchases has been completed. And with durability, once a transaction has been committed, it should be stored, saved, and have a redundancy in case of system failure. A disaster recovery strategy should restore any data to the last moment of stability before the system crash. Imagine you've been paid today, but the bank's servers crash. They restore their systems, but only have data up to yesterday. Your money's gone, and there's nothing you can do about it. That's why durability is so important. ACID-compliant databases are critical in the modern world. Everything is electronic, and huge amounts of data and money are transferred every second. Databases without ACID principles can have data inconsistencies, lost updates, data corruption, and compromised security. So if you're a Patreon member, you can head over to patreon.com/tleveltactics and get the task sheet for this video. Have a go at task 1. It'll take you about 20 minutes. And if you're not a member of the Patreon yet, head over to patreon.com/tleveltactics and get signed up so you can get access to all the task sheets for all of our videos and all the other exclusive content available. Pause the video here, have a go at task 1, and then come back when you're ready to move on to part 2. So let's have a look at this thing called normalization. If we were to collect an individual's personal data, we might want to collect a few things. For example, we might want their name, their address, and their phone number. That's 3 bits of information. Here's a fictional example of what we could use. We could have Mr. Oliver Smith, who lives at 45 Oak Lane, Hulme, Manchester, M1 2AB, United Kingdom. And his phone number, 07123 456 789. But there's actually a lot more data here than just 3 items. And this is known as unnormalized data. If we were to create a database table with the headings name, address, and phone number, we wouldn't be able to just query the house number, we'd have to return the whole address. Databases use a process called normalization to organize data, reduce redundancy, and improve data integrity. And normalization has different forms. Each form is a set of criteria the data within the database has to meet. And each form builds upon the criteria of those before it. Most databases will be normalized to the 3rd normal form. However, some can be normalized to 5th normal form or higher. A table in a database is in 1st normal form if it contains atomic values. An atomic value is any data that cannot be subdivided any further. Let's revisit the name from our example of Mr. Oliver Smith. We've identified the name of the person, but it actually contains 3 separate bits of data. We've got the title, which is Mr., the first name, Oliver, and also the surname, Smith. The same goes for the address, 45 Oak Lane, Hulme, Manchester, M1 2AB, United Kingdom. Here we have the house number, 45, the street name, Oak Lane, the area, which is Hulme, the city, Manchester, the postcode, M1 2AB, and also the country, United Kingdom. And we can do exactly the same with the date of birth. Here we've got a date of birth which is 18th of October 1985, formatted as 18/10/1985. We can split this down into the day, which is 18, the month, which is 10, and the year, which is 1985. Now we can't break any of this data down any further, so it's considered to be in 1st normal form. By atomizing data, we can improve data quality and accuracy. By making each part of an address its own field, we can make sure we have every part of it with our data verification. Think, what if someone forgot to add their house number? Well, we can make that a required condition when it has its own field. We can also make much more detailed queries, such as identifying all customers that live in Manchester, or how many have listed their title as Mr. Smaller data entries means much faster retrieval of data if we don't need all the data attached to a record. And it's also the first step towards second normal form. So now that we've normalized some data, here's a look at a table in first normal form. We can see we have our unique primary key customer ID on the left, and then we've got our additional columns of title, first name, surname, house number, address 1, address 2, city, and postcode. To reach second normal form, tables in a database must first meet the criteria of first normal form. Second normal form involves looking at tables in the database and removing any partial dependencies or irrelevant data. Take a look at this table that shows grades for students. We have student ID, course name, instructor name, and the grade. But there's lots of data here that we don't need to identify their grade. For instance, we don't need to know the name of the course or the instructor. All we really need to know is the student ID, the course ID, and the grade. The other data should already exist elsewhere in the database, and we don't need to duplicate it here. To normalize this data, we'll need to split it down into two tables. We can have TBL courses and TBL grades. Our courses table has the names of courses and instructors and uses course ID as a primary key. And our grades table now shows the grades that students have received for each course. The grade table uses what's known as a composite key, using two primary keys, student ID and course ID, to make each entry unique. With second normal form, we can eliminate data redundancy. So for instance, the course name and instructor name are no longer repeated in the students table, reducing that data redundancy. We can improve data integrity. So changes to course names or instructor names can be made in one place in the courses table without affecting multiple records in the students table. We can also simplify data maintenance. Each table now has a clear purpose, making it easier to manage and update data. And also, our data is now ready for third normal form. To reach third normal form, tables in a database must first meet the criteria of both first normal form and second normal form. Third normal form looks at removing transitive dependencies. A transitive dependency is where a non-primary field key relies upon another field that is a non-primary key, or doesn't rely upon any other field. Once transitive dependencies are removed, what's left should be fully dependent on the primary key. Now that sounds a little confusing, so let's take a look at how it works. Let's use the courses table that we've just got to second normal form. Here, course ID is the primary key. Now, course name is directly linked to course ID and will likely never change. However, instructor name is not necessarily always linked to either column, as the instructor could change if a member of staff leaves or a new one joins, or there could be multiple instructors on the same course. To reach third normal form, we'll need to remove the instructors and put them in another table. So we'll now have an instructors table, a courses table, and a course instructors table. Instructors now have their own table and their own primary key. Courses have their own table. And our third table created shows what courses instructors are teaching on, as multiple instructors could teach on a single course, and each instructor could teach multiple courses. We've now removed all redundant data from each table, and can change data in a table without impacting any others. For example, if Dr. Johnson were to change their name, we can change it once in the instructors table and not have to hunt through a much bigger table to find every instance of it. Third normal form further reduces data redundancy, ensuring attributes are only stored in one place. This means any changes to data are only made in one place and reducing data inconsistencies across the database. This makes data maintenance much easier and locating data far more intuitive. Reaching third normal form is a baseline that most organizations and data scientists use. However, some organizations may require you to go to fifth normal form and compartmentalize data even further. Third normal form will work in the vast majority of cases, however. Let's have a quick reminder of some key terms that we've used in normalization. Functional dependency, which occurs when the value of one attribute or group of attributes determines the value of another. A partial dependency, which exists when a non-key attribute is dependent on only a part of a composite primary key. This is what second normal form aims to eliminate. And transitive dependency, which occurs when a non-key attribute is dependent on another non-key attribute. Third normal form aims to eliminate these dependencies to ensure that all attributes are directly related to the primary key. So if you're a Patreon member, you can head back to the task sheet and have a go at task 2, which is all about normalization, and you're going to normalize some different data sets. It will take a little while, about 60 minutes, but it is the last task for this video. So pause the video here, have a go, then come back when you're ready to finish things off and have a go at some exam questions. So in this video, we've identified the properties of ACID-compliant databases, and we've also applied some normalization techniques to data. Let's try some exam questions to finish things off. Here's the first one. Explain the concept of isolation in the context of ACID properties. Why is it important in a database management system? And the second one, what is the purpose of third normal form in database normalization? Describe the criteria that a table must meet to be in third normal form. And that brings us to the end of the video. In the next video, we'll be looking at presenting data in different formats. So make sure you're subscribed at youtube.com/@tleveltactics to be notified when that one comes out. And if you haven't visited the Patreon yet, head over to patreon.com/tleveltactics to take a look at all the exclusive content that our members get. Thanks for watching, and see you next time.